Hello and welcome to Kara SAT Tutoring, the only tutoring service in the world that provides free and high quality SAT tutoring to low income students all around the world. So if you're a low income student and you're just now watching our videos and just knowing about us, then head down in the link below where you will find a qualifications list, and if you meet with those qualifications, you will get a free and high quality SAT tutor. Our SAT tutor's average score is 1500, so you're guaranteed that you are going to get a good score. Today's topic is going to be a fairly quick one. Just a little reminder to anybody who's come onto this videos. Our aim is to provide you quick, short little snippets of the SAT, just so that you know what happens back here at the tutoring. So today's discussion is going to be exponents. Now, exponents are one of the most frequently missed concepts and questions on the SAT, and that's for a good reason, because once you're in the third or fourth, once you're in the SAT math no calc or SAT math calc, your brain's already tired and you're really weary, you're really tired. So you are liable to mix things up. But don't worry, because we are here, I am here, and I'm going to show you some of the common rules, and then we're going to attempt some of these really hard problems. So the first rule is this, that if you have, for example, 5 to the second power, and you're multiplying it, and this is very important, this multiplication. This rule only works when it's multiplied. 5 to the third power. You can write this whole thing as 5 to the fifth power. Or basically, you're adding the exponents. Now, there are two criteria for this to take place. The first criteria is obviously that you have to have these two things multiplied, but also the bases. So this big number, so after an exponents, you'll see that, so this big number right here, this A, that B, those are what we call bases. So this base and that base have to be the same. If those two things meet out, then you can add these exponents. These exponents can be negative, these exponents can be fractional, decimal. You can add whatever you want. They can be any type, but you can add them. And so in a similar way, we have another rule. This again only works when you're dividing and you have again the same basis, which is, let's say you have 5 to the third power divided by 5 to the second power. So again, it only works when you're dividing and you have the same basis. You can write this whole expression as the base and the subtraction of the top exponent, so that's 3, minus 2, which is the bottom exponent, so that would be 5. And this works, and you'll see why, because if we do 125, that's 5 cubed divided by 25, well, we get exactly what we got. So we don't need to actually expand the exponents. We can use rules to help us out. All right, so those were the first two rules. But the third rule is that, let's say you have an exponent, let's say you have a base 5 to the second, and then it's in parentheses, so that 5 to the second, and then that whole term is to the third power. Well, then you can simply, what you can do is you can simply just multiply these exponents. So not add them, multiply them. So 2 times 3 would be 6. So this is a fairly simple one. The next thing, and again, these are really common rules. Further videos we'll go into a little bit more advanced rules. The next common rule is that, let's say you have let's say you have 5 to the negative second power. What that means is you will make this base you will write a reciprocal of that base. So reciprocal is just, if it's 5, the reciprocal would be 1 over 5. So basically 5 is actually written 5 over 1, and so you're just switching the numerator and denominator. And so if it was 1 by 5, the reciprocal would be 5. So you write the reciprocal of this 1 divided by 5, and then that 2 power goes right here. So 5 to the negative second is the same thing as 1 over 5 to the second. So nothing becomes negative. The negative just means that you're flipping it over. Alright. The next one, and this I think will be the last one so we can solve these questions, is if you have, let's say a divided by b, and that whole fraction is to a power, like the third power, then what you can do is this little thing that allows you to distribute that power to the numerator, so a to the third, and the denominator separately. Okay, so remember, we are not doing a to the second, b to the 1, because 2 plus 1 is 3. No. What we're doing is we're distributing that fraction, that numerator onto that exponent onto the numerator and the denominator. Alright, so now since we know those 5 common basic rules, again, sorry for that, for those 5 rules, we should be able to now start answering these questions. Alrighty, so this question right here, x, y to the third, and again, whenever they're just like this together, whenever they're just a, b, that just means it's a times b. Okay, so if it's to the negative 7th power, and oh, by the way, so that a divided by b, I just talked about how you can distribute that exponent to the both numerator. That also applies for if you have a big term, like what we just see here. You can distribute that exponent to each one. Okay, moving on. Okay, so this one right here, x, y to the third, z to the fifth, to the negative 7th power. So the first thing we need to do is we're not going to open the brackets and distribute the exponents everywhere. What we're going to do is we're going to think of this. This is a very good strategy here. Think of this whole term as a. So now we've gotten rid of all the x, y, z's. So now just imagine it's a to the negative 7. So like we talked before, we would do its reciprocal, which is 1 over a, and then we just put that power over to the a, like that. Simple, right? Now, that was step number 1. Step number 2 is we just substitute a. So we just say that a is this whole mess right here. So now we're just going to substitute it. So now we just have x, y to the third, z to the fifth over 7. And now we can start distributing. So what this means is that x to the 7th will get an exponent, the y to the third will have an exponent over that, and then z to the 5th will itself have an exponent like that. And remember that rule where if you have an exponent of an exponent, you can multiply those. So our final comes out to be x to the 7th times y to the 21st times z to the 35th. Alright. Okay. So we just did 1 here, which is number 1. I want you guys to do number 2 and number 3. They're not that different, and the reason that I ask you to do 2 and 3 is because these two are a little bit harder, so this would actually stretch your mental capacity and ask you to be a little bit more risk-taking. The answer of these two questions are going to be in the link below. Again, this is Kara SAT Tutoring, free high quality tutoring to low-income students, signing off.